Welcome to the second part of the presentation on classification of igneous rocks. In the first part, we have seen two bases of classification, that is depth of origin of igneous rocks and also the mineralogical composition of igneous rocks. In the second part, we will see three broad bases of classification, that is texture of igneous rocks, chemical composition and also the chemical composition and mineralogy of igneous rocks. Here the first one in the based on texture, here the grain to grain relationship of the rock is considered. Based on crystallinity, granularity and fabric, igneous rocks can be classified. These are some of the oldest classifications of igneous rocks based on crystallinity. What is crystallinity? Crystallinity indicates the amount of crystalline matter and also the glassy matter that is present in an igneous rock. We have three varieties of igneous rocks based on crystallinity, that is holocrystalline. Holocrystalline means the entire igneous rock is made up of grains, crystals, that is the best example being granite and gabbro. In the second variety, which is called as the holohyaline igneous rock, the entire rock is made up of glassy matter. Glass means it is made up of non-crystalline matter. The best examples are obsidian and pitchstone. In the third category, that is merocrystalline or mesocrystalline igneous rock, we find a combination of crystalline matter and glassy matter. This category is exemplified by rocks like felsite and basalt. Felsite being a hypabyssal rock, whereas basalt is a volcanic rock. Based on texture itself, we have classification based on granularity. Here two broad kinds are there, phaneretic and aphanetic. Phaneretic means the grains in the igneous rock can be seen with the naked eye or with the help of a hand lens. Examples being granite and syenite. Aphanetic means the grains are not visible to the naked eye. It may be seen with the help of a petrological microscope. Examples being basalt, phaneretic. Here we find three main varieties: coarse grained igneous rock, medium grained igneous rock and fine grained igneous rock. Coarse grained igneous rocks, in which we can see the larger grains easily identifiable with the naked eye. Medium grain, it is in between coarse grained and fine grained, and here again the grains can be identified with the help of a hand lens or even with the naked eye. Fine grained igneous rocks are those in which the grains are very fine. Of course, there are limits given, that is the diameter of the grains are also mentioned in classifying coarse grained, medium grained and fine grained rocks. These rocks are shown in the photos here, and we can see the first one being granite, second one again you have a medium grained rock, and the third one you have fine grained rock, basalt. Aphanetic means it is a glassy rock. Here grains are not seen with the naked eye. You have to depend on other instruments for identifying the grains. The best example is again obsidian. The fourth basis of classification is chemical composition of the igneous rock. A number of classifications are available based on the chemical composition of igneous rocks. Remember that the chemical composition of igneous rock was used to be found with the help of wet chemical analysis, which was a very time consuming process. Nowadays we have modern instruments available with which we will be able to find the chemical composition of igneous rocks in a faster manner. But here again the analysis is costly. The various bases of classification on the chemistry of the igneous rocks include the silica percentage, that is SiO2 percentage, alumina saturation, that is Al2O3 saturation, Niggli values. These Niggli values have been made on the basis of certain chemical elements. Then alkali lime index, that is Na2O, K2O and CaO are used in finding out the index. Then CIPW classification. In this CIPW classification, chemical analysis has been used to find the mineralogy of the rock also. Based on silica percentage, 4 categories of igneous rocks are recognized. The first one, that is those igneous rocks containing more than 66% of SiO2, they are called as acidic igneous rock. Example being granite and rhyolite. They are also called as felsic igneous rocks. The second category has SiO2 ranging between 66 and 52%. These are called intermediate igneous rocks. The examples include syenite and trachyte. The basic igneous rock, the third category, contain SiO2 percentage between 52 and 45. Gabbro and basalt are the examples. The ultra basic igneous rocks have silica percentage, SiO2 percentage less than 45%. Dunite, pickrite are examples. Remember that if you consider the specific gravity of these rocks, acidic igneous rocks have the least specific gravity, and the ultra basic igneous rocks in general have the highest specific gravity among the 4 types of igneous rocks based on silica percentage. Based on alumina saturation. Initially, geologists considered the SiO2 content of an igneous rock as the most important one in determining the type of igneous rock. But later on it was argued that it is not SiO2 percentage, it is the percentage of alumina in relation to the alkalis that determine the nature of igneous rocks. Accordingly, the molecular proportion of the alkalis with alumina in a rock was used for the classification of igneous rocks. This is called alumina saturation classification. In this, molecular proportion of oxides is calculated by dividing the weight percentage with that of the molecular weight of the concerned oxide. For example, CaO has the molecular weight 56.08. The percentage of weight percentage of CaO will be divided by 56.08 to get the molecular proportion. Based on this, we have different categories. They are peraluminous igneous rocks, in which we find that Al2O3 content is much more than the combined percentage of Na2O plus K2O plus CaO, whereas metaluminous has Al2O3 content less than CaO plus NaO plus K2O, and Al2O3 will be more than Na2O plus K2O. Subaluminous means Al2O3 rarely equals to Na2O plus K2O. In peralkaline igneous rock, the alumina content is very low compared to the added content of Na2O plus K2O. This is a very popular classification of igneous rocks. Niggli has classified the igneous rocks based on certain oxides. What he has found out is to use certain oxides, combined percentage of certain oxides, and he has labeled them as Al, Fm, Alk, C, etc. In this, Al means it is the combined percentage of Al2O3 plus Cr2O3 plus rare earth elements, whereas Fm will be calculated with the content of FeO, MgO and MnO. Na2O plus K2O plus LaO2 together will give Alk values. CaO plus BaO plus SRO will give the value of C. this chemical analysis will be recalculated to 100. Al, Fm, Alk and C values are plotted against the molecular number of SiO2. Corresponding SI values is used for grouping rocks into one of the 3 suites of igneous rocks. This classification is not so popular now, but still it has historical importance. Here we find that SI value is plotted on the x axis and Al, Fm values are plotted on the y axis, vertical axis. A number 176, SI value 176 indicates that the rock belongs to calc alkalic suit or Pacific suit, whereas the number 158 shows that the rock belongs to the alkaline suit or Atlantic suit. 145 suggests that it belongs to the potassium suit. So, the intersection of aluminum value with Fm values, when that intersection point is put down with the help of an arrow towards the x axis, it intersects the SI value to get the SI value. This SI values are 176, 158 and 145 for various suites of rocks. Alkali lime index is used for the classification of igneous rocks. This is based on the alkalinity of rock. This was devised by Peacock in 1930. Plots of CaO versus SiO2 and Na2O plus K2O versus SiO2 are used in this classification. The alkali lime index is determined in this manner. Here we find that the CaO value is plotted against SiO2 value, then Na2O value, Na2O plus K2O value together will be plotted against SiO2 value. The intersection point of these two curves will give, when projected downward, will give the SiO2 value that determines the type of suit to which the rock, igneous rock belongs to. We find that there are 4 varieties of igneous rocks in this category. It is called calcic, calcalkalic, alkali calcic and alkalic. In the first one, the alkali lime index is more than 61%. The best examples are basalt andesite rhyolite series. Tolitic basalt andesite rhyolite series belongs to the calc-alkalic suit, where the alkali lime index is between 61 and 56%, whereas the last one, alkalic lime index value will be alkalic, suggests that it is the value is less than 51%. Nepheline cyanide complexes are the best examples of such sort of series. Based on chemical composition and mineralogy, a different type of classification is possible. This is called the most popular one is called CEP-UGC norm classification. Earlier, when discussing in the first part, I told that model analysis gives the actual volume percentage of minerals in an igneous rock, whereas norm gives the calculated mineralogical composition of an igneous rock. Calculated mineralogical composition is obtained based on the conversion of a whole rock chemical analysis into various minerals. How this is done? This is based on the rules in physical chemistry and the order of formation of minerals from magmas. Order of formation of minerals from magma is based on Bowen's reaction series. In that we find that calcic plagioclase is the first form. Similarly, we find that ferromagnesium minerals are the first to form, and again accessory minerals are in early formed minerals. Using this, norm of a rock is calculated. CIPW is the acronym for scientists Cross, Eddings, Person and Washington. Norm, CIPW norm, which was devised in 1902. It is the most commonly used classification nowadays, and it has withstood the test of time. Although it is more than a century old, it is still a very popular classification. weight percentages of oxides are converted into weight percentages of anhydrous, salic and femic group of minerals in this classification. The photographs of these 4 scientists are shown: Cross, Eddings, Person and Washington. These are 4 Americans. Their effort has made this classification possible, and they have used the principles of physical chemistry for arriving at the chemical composition and also the mineralogical composition of an igneous rock. The salic and femic groups, it is divided into salic and femic groups. Some of the important minerals of the salic groups are listed here: quartz, orthoclase, albite, anorthite, nepheline, leucite, corundum is an accessory mineral. Some major minerals of femic group are also shown here. It is olivine, hyperstein diopside, these are pyroxenes. Then wollastonite is there, it is called a pyroxenoid, and oxides like magnetite, ilmenite are also included, and pyrite is a sulfide which is included under the category of femic group of minerals. The proportion of salic and femic groups of minerals determines the class to which an igneous rock belongs to. There are several advantages and disadvantages for this classification, CEC-UGC norm classification. The advantages are listed here. This classification considers chemical constituents of essential minerals. So, normally we do not consider the secondary minerals for classification, we do not consider the accessory minerals also not considered here, because we find that the most important minerals considered are feldspars, feldspathoids, quartz and also olivine and different types of hypersteins. They determine the name of the rock. The second one is that mineralogy of aphanitic and glassy rocks can be calculated. Here you find that volcanic rock, many volcanic rocks are fine grained or glassy, in which the model analysis is not possible. So, here what we do is we depend on the chemical composition of the rock, and based on that we arrive at the mineralogy, which was not possible with model analysis. Thin section studies will not help at all. Then it is this particular CEC-UGC norm is used for metamorphic rocks also, in the sense that the metamorphic rocks are products of recrystallization of some pre-existing rocks. From this calculated mineralogy, we will be in a position to know about the mineralogy of the suspected mineralogy of the parent rock. These are the advantages. The disadvantages are that chemical analysis data is essential, which is a very costly one and also time consuming one. Many a time we will find it difficult to get the right instrumentation for analysis. The second disadvantage is that the calculated norms of most of the igneous rocks do not exactly match with that of the model mineralogy. There is a discrepancy, because many a mineral is not considered in the classification in CEC-UGC norm. Then the very common minerals like micas, biotite, muscovite, amphiboles, hornblende, etc., do not find a place in the list of minerals given in CEC-UGC norm classification. A tabular classification. This tabular classification is a very student friendly classification. Here you find that almost all the criteria, all the different important bases of classification are taken into consideration to give a classification of igneous rocks in a table. So, this is very good for a beginner. The relative proportion of feldspars and quartz are considered in this classification. The mode of occurrence, whether it is plutonic, hypabyssal or volcanic, is also considered. The percentage of SiO2 and free quartz also is considered. The proportion of potash feldspar, calcic plagioclase and sodic plagioclase are also considered in this classification. The concept of silica saturation is also included. Thus, this tabular classification although it looks a very simple one, it has taken into consideration many different bases of classification. This was given by G.W. Tyrrell, and even now this is a very popular classification, especially for the beginners. The classification is given in a tabular classification is provided here. You can find that the extreme end shows the mode of occurrence of the igneous rock, plutonic, hypabyssal and volcanic. At the bottommost portion you can see the silica percentage given. At the topmost saturation concept is given. In the second row you can find the type of feldspar and quartz that is present, and towards the right hand end you can see the presence of mafic minerals in the rocks, consideration for the mafic minerals present in the rock. Thus it is a very good classification for students who are initiated into petrology. So you can find that you can find out the corresponding rocks in the corresponding rock of a plutonic rock can be found from this classification. Then again the volcanic equivalent of a plutonic rock also can be found out from this classification. So, we have seen a number of classifications here now, and we can see that the classification of igneous rocks, it is not an easy one. First of all, because the number is huge number of igneous rocks are discovered from different parts of the world. And again remember that the composition of an igneous rock, various igneous rocks, it is a continuous composition rather than a composition that can be given in watertight compartments. So, again personal preferences of many petrologists have come into play in these classifications. Thus, there are different schemes of classifications available, and each classification you can see that has its own advantages and disadvantages. The type of classification rather depends on the user. For example, a beginner may use Tyrrell's classification, whereas a researcher may use CAPW classification. A person who has the advantage of doing chemical analysis again prefers a CAPW classification, whereas those who are very particular in studying the details of an igneous rock, doing research in igneous petrology, they will depend on IUGS classification for identification of their rocks and also for comparison. And if you see all these classifications, it can be found that no single classification can satisfy all petrologists. So, there are question marks in each and every classification. At the same time, the International Union of Geological Sciences have made concrete efforts to arrive at a classification, the IUGS classification, which satisfy most of these classification, because they have considered minerals as the units for classification, because mineral classifications have to be preferred as they are the building blocks of rocks. A number of sites have been visited for getting the images here. I acknowledge their contribution, and I thank you very much for listening to this presentation. Thank you very much.